Bismillahirrahmanirrahim. Welcome to my induction heating project. This is the double-ended Class E Resonant Inverter induction heating application. This is the overall system, and I am using induction heating to boil water, and the system at this moment is running, and you can also see the voltage waveform on the oscilloscope. So I will now provide a brief overview of the components and the circuitries. So first of all, we start with the control signals. This is the control signal. It is providing the necessary sequence, frequency, sequence and required voltage levels to turn on the MOSFETs. Here is the double-ended Class E resonant inverter. I am using only 2 MOSFETs and 2 inductors. Then comes the intermediate inductors, then comes the resonant capacitors, and then comes the resonant coil. Inside the coil I have placed a metallic container. It is a normal metallic container which has water. So I will, in fact, what I'm doing is I'm using induction heating to heat up the metallic container, and I have placed water as the application, and this heated container boils the water. So you can see that the induction heating is creating thermal energy in the metallic container, and I am getting water boiling. Then the power supply. This is a DC power supply. I am giving 28.8 plus 28.8 volts, and the current being consumed is 3.12. And here is the oscilloscope outputs. Next, I will also show the waveform across the coil. It will be a sinusoidal waveform at the higher frequency. Yes, so now what I have done, I have now relocated the oscilloscope's probes. I have located them across the resonant load, and here is the resonant frequency on the oscilloscope. So this is the resonant frequency appearing across the induction coil, and it is due to this we are getting electromagnetic induction and then heat process. And here is the DC power supply. Yes, now one very interesting feature of this double-ended Class E resonant inverter is that at this moment we have inserted the induction load, and the water is boiling, and our DC power supply is giving 28.8 plus 28.8 volts and 3.12 amperes. However, if we remove the load, so and at the same time it's also resonating, so the oscilloscope shows that the signal is oscillating. So now if I remove the load with the help of these pliers, if I remove this load like this, now what happens is that now under no load conditions the system is still resonating, and this is the new power, which is now only 0.64 amperes. This is the ampere, and the voltage is 31.6 plus 31.6 volts. So we are also achieving energy efficiency. We have saved energy, that under no load conditions the system resonates and consumes less amount of power. And if I can show at a wider angle, that I will take the induction load again, and I will place it, return the load, and the power is now increased. The power being delivered is now increased. So 28.7 plus 28.7 volts and 3.12 amperes. And if I remove the load, and look how the current changes. So I'm going to remove the load, and this is how the current changes. And we also observe changes in the voltage. So this is the one one attractive feature of using the double-ended class E inverter. So yes, and now I will now reinsert the induction load like this and get resonance. Power is being delivered, and you can see that now, since you can see vapors, so this means that the system will start boiling, and yes, you can see the boiling process has started. So thank you very much for your time. If you have enjoyed my video, please do consider to subscribe and hit the like button.